Welcome. Today we will see transformer. It is an AC device used to change high voltage low current AC into low voltage high current AC and vice versa without changing the frequency. Now in this principle of operation of transformer works on principle of mutual induction, according to which an EMF is induced in a coil which is current when current in the neighboring coil changes. Working of a transformer. When current in the primary coil changes, being alternative in nature, a changing magnetic field is produced. This changing magnetic field gets associated with the secondary through the soft iron core. Hence, magnetic flux link with the secondary coil changes, which induces EMF in the secondary coil. Now this is the rectangular core of the transformer, where this is the primary side and this one is the secondary side. When current is passing through the primary, then EMF get induced in the primary, and the sum flux of this primary is get linked with this secondary coil. And according to Faraday's law, EMF get induced in the coil. So it is required for working of the transformer, there should be the change in flux. Therefore, transformer always works on AC supply. Because for working of a transformer, change in flux is required, which are getting from AC supply, not from DC supply. Transformer is always works on AC supply, not on DC supply, to satisfy Faraday's law of electromagnetic induction, which is the basic working of the transformer. Because in Faraday's law there is a change in flux, and when change in flux is occur, then only an EMF get induced in the transformer, and which satisfy the actual working of the transformer, which can be changes the voltage from primary side to secondary side, or which can be increase the voltage in the secondary side as compared to the primary side, or which can be decrease the voltage on the secondary side as compared to the primary side. Constructional details of the transformer. Transformer basically of two types, core type transformer and shell type transformer. Now this is the shell type transformer. In this shell type transformer, windings are wrapped around the center leg of the laminated core. And in core type transformer, windings are wrapped around two sides of the laminated square core. Single phase transformer. A single phase transformer, two or more windings coupled by a common magnetic core. Here this primary winding and secondary winding both are coupled with this common magnetic core. Means on one side of that magnetic core primary winding is placed, and the winding which is connected to the supply is called it as the primary winding, and the winding which is connected across the load is called it as the secondary winding. Now we will see ideal transformer. Ideal transformer means where the input is equal to output. Zero leakage flux. Fluxes produced by the primary and secondary currents are confirmed within the core. Two windings have no resistance. The windings have no resistance. Induced voltages equal applied voltages. The core has infinite permeability. Reluctance of the core is zero. Negligible current is required to establish magnetic flux. Lossless magnetic core. No hysteresis or eddy current loss is taking place in the ideal transformer. So it satisfies the condition of ideal transformer, where input power is equal to output power and no losses, and losses is zero. Now transformer efficiency. For transformer efficiency, the formula is efficiency is equal to output power upon input power, which is again defined as output power upon losses plus output power, that is equal to output power upon copper loss plus core loss plus output power. Here the total losses is divided into copper loss and core loss. Efficiency is again, efficiency's formula is efficiency is equal to Vs Is cos theta divided by copper loss plus core loss plus Vs Is cos theta. Now Vs Is cos theta is nothing but the output power, means voltage across secondary side into current in the secondary side into cos of angle theta. Transformer voltage regulation, and its formula is VR is equal to Vs at no load condition minus Vs at full load condition divided by Vs at full load condition. This Vs at no load condition we are measuring by removing the load across the secondary side. Once the load is removed, whatever the voltage we have measured, that is called it as the voltage at secondary side at no load condition. And when we are connecting the load across secondary side, that is denoted by Vs at full load condition. Transformer test. The performance of transformer can be calculated on the basis of equivalent circuit. The four main parameters of equivalent circuits are R01 as referred to primary or secondary R02. The equivalent leakage reactance X01 as referred to primary or secondary X02. Magnetizing susceptance B0 or reactance X0. Core loss conductance G0 or resistance R0. The above constants can be easily determined by two tests. First one is open circuit test, which is called it as the OC test or no load test. Second one is short circuit test, which is called it as the SC test or impedance test. These tests are economical and convenient. These tests furnish the result without actually loading the transformer. And when there is not a loading, so the losses are automatically minimized over there. Transformer. That what is the working principle of transformer? Explain types of the transformer. Explain efficiency and regulation of the transformer. Thank you. 7 मिनिटं झाले.